My background is, I recently retired from the city of St. Paul, Minnesota, as a spatial data manager of sorts. My background is in municipal engineering, from the perspective of I worked in just about every department at the city there, or from in public works, not department, every section of the public works in at one time or another. So I was kind of privy to how everybody collected their data. And over time, I became kind of like the data czar, and captured a lot of the information and set up a lot of it up for distribution in automated forms over the years. So that's generally my background. And then the project that we're going to talk about has been kind of like a pet project that I've wanted to do for quite a while. I always knew that the technical aspects were kind of pretty straightforward to get it done. What the project has kind of taught me is that it's a lot of understanding people's needs and how they want to be able to share things, and if they want to be able to share things, or why they can't share data, that kind of thing. So that's been a lot of the uphill struggles with moving the project along. But the technical aspects are pretty straightforward. So it's actually been coming together really nicely. Um, so hello, everybody. The project that we're going to be talking about is something that was started, back in 2020. There, as indicated on the slide there, and it was pulled together by a few different groups at within the state of Minnesota. The main one being the Gopher State One Call administrator, which is Barb Cedarberg. She's the operational kind of control and chair of the that group, and they run the ticketing system inside the state of Minnesota for underground digging. Another component, or another group of people that got involved early on, was the Geospatial Advisory Council for the state of Minnesota, and Steve Swayze is the vice chair, and he's kind of handling administrative control of the project. And then I myself, Bob Vasquez, I'm running the kind of the technical side of pulling the project together and then actually building it. So it's a public-private kind of partnership, and we've been rolling along here for a few years, and we're over the main hump of development and starting on kind of the backside of the development of the project. Kind of we're on the downhill slope now. So we're coming up on setting up documentation, fleshing out kind of administrative tasks, that kind of thing. So the project's moving along very well. The long-term outcomes that we're expecting is the generation of some high quality, hopefully GPS facility operator maps of underground utilities. The idea here is that we're facilitating the sharing of the data, and the end goal is the hopes that if the data can be shared easily, people will improve their data over time, with the option of it being able to be distributed in this way. So the idea generally is for the project to facilitate the sharing, and hopefully it fosters the improvement of the data sets that are being shared over time. We're shooting for these maps of underground facilities, and to be viewed by the accredited designers. So there's a whole kind of group in the project that's related to how do we accredit designers, locators, excavators, and set them up so that they can share and access the data from the call before you dig end of the equation. So we're shooting for that safer excavation, increased efficiency, and overall cost reduction. All the previous presentations have jumped right into all of that stuff already. So I'm going to kind of glide over that part of it. But the technology exists to enable this real-time or near real-time viewing of underground utility maps. The GSOC One Call ticket is the control that is used at the state of Minnesota for selecting the area for viewing the maps. So if you're looking at the map there, the dashed line is a 100-foot buffer that we place around the actual area of interest for the ticket, for the dig ticket, and that's the black line. And this is just a standard that we're using for the actual project itself. Is that 100-foot buffer, it gets applied to all of the tickets. So viewing access and time by the users is limited to the life of the ticket. So the ticket, when it comes into the FuzionView system, has got a begin date, end date. So when the end date is reached, the data is purged from the FuzionView system. The FuzionView engine only grabs the data within that dash line, so that 100-foot buffer, and it doesn't grab anything else. It just grabs that chunk of data there, and it goes and grabs it from the data provider service that is connected up. So we piloted this system in 2022. We're in kind of a beta test stage currently. We're really kind of focusing right now on testing the connections to all the different services that are providing data to the FuzionView engine. Right now, we've got 10 data providers that are contributing data, and we've got another 3 on deck that we're starting to pull in information for. So within a month or two, we'll have 13 to 15 data providers that are hooked into the engine, and we're in this test mode of just testing the connections currently. And then, implementation ready, we're looking at the first quarter of 2025 for being like the real, first kind of blast at putting this thing out and letting end users or users from top to bottom be able to access the information. Common Ground Alliance actually did a next practices initiative about this project. They did it, it was published in 2023. I threw the link in there at the bottom of the slide there, and it provides a very good overview of the project and kind of what we're targeting with the project and where it's going to go. It's actually held up pretty well as far as long-term viability for what they wrote up in their initiative in their write-up. Collaborations with similar efforts. We've actually done quite a bit of background research early on. A couple of these have already been mentioned in previous presentations. So, the Canada subsurface utility mapping, that's, Steve Slusarenko, and then the Colorado stuff was brought up. And we actually went out and looked at quite a few different ways that this type of data sharing could be accomplished. And, we've got different rules at the state of Minnesota versus some of these others. The Colorado version of things actually works pretty well, but they're kind of doing it at the project level, not necessarily at the state like we're trying to do. So we're messing around with trying to get all of the sharing working across, it's like 2,000 plus data providers that are registered with the Gopher State One Call system for the state of Minnesota. So that's the end goal, is getting all of them to be able to share their data with the FuzionView system eventually. The plan is that the FuzionView engine itself, the actual piece of software that does this reorganizing of the data that is coming in from all of these different providers, it consists of it's an open source project. The idea there is that it's all set with APIs that are distributing the information for all of the interfaces that I'm going to show. The interfaces that I'm going to show are actually built just for our project purposes. So we've got a way of demonstrating what can be done. But because it's all API driven, the APIs can be used instead to integrate it with any other system. So the FuzionView engine itself is only in place to grab the information from these remote data providers and their systems, pull it together, homogenize it into a FuzionView version of the data, and then provide that as an API that can be used for presenting the data online. In the future, there's the way that the FuzionView engine has been built, it's set up to be able to handle 3D visualizations. Right now, we're kind of focusing on the 2D aspect because most people currently have services that are able to distribute their information in 2D, but 3D is coming. You look at it from the LiDAR side of things and all of the different kinds of standards that are starting to emerge. You can see that 3D is the up and coming piece of the equation and making a lot of the underground side of things much more accurate and then the way that you can collect the information as well. The data, from the LiDAR perspective, for example, is you can grab that data very easily now. And there are tools that are starting to emerge for the visualization side as well. So there'll be other kind of flexibility things that are be added in there. The FuzionView engine can be configured with data schemas for different business types, that kind of thing. The business that we're in the process of building for right now is underground utility location. Real quick, I already kind of summarized this, but early in 2025, we'll have a version that will be available for kind of review from the top to the bottom, from front to back. All elements will be in place. In the beta test, we've been kind of focusing on testing things with the MnDOT, Department of Transportation for the state of Minnesota, and an engineering group called WSB. And the MnDOT side is they're acting like the data provider, the main data provider tester. And then WSB is kind of like, think of them as maybe a contracted locator, or they could be a design engineering firm, or they could actually be an end user as well using the data out in the field. Working with these additional facility operators that we've been bringing on, the 10 to 15 that I was talking about, we'll start testing the connections with the system, and then this this beta testing that we're talking about, it'll be kind of the follow-on to actually after the data has been pulled in, how do we use that data out in the field? Is it effective the way that we've built things? Have we pushed the technology in the right way? So getting into the FuzionView engine itself, we're all about augmenting the 811 call. We're not trying to change any of the existing ticketing system. We're just trying to add more data to the discovery process. So, we must comply with one call laws, but there's not really that many in place currently about the, providing the data on the mapping side. So, again, we're not trying to change the current system. We're just trying to augment it. So the key to the FuzionView process is to go where the data is. So what we want to do is get to the where that data is being captured. The data is being captured, from the data maintainer's perspective for their own business needs. And those maintainers can be many and varied inside of an organization. Data maintenance can be distributed inside of an organization with different folks grabbing data for different reasons. So inside of an organization, we have to pay attention on the FuzionView engine side to that aspect. And then the data schemas are many and varied. The design of the FuzionView engine is targeted at simplifying the presentation of these many and varied schemas into a unified version for data presentation. So in general, the kind of application flow for the FuzionView engine is that you're going to have a ticket viewer interface. Basically, it's the guy out in the field, or the guy that requested, or the entity that requested the underground dig ticket, and they're going to have access to that ticket viewer version of the application flow. Then there's also going to be a facility operator dashboard. That's the mapping data, viewed by data or design engineers and facility operators, contract locators, excavators. So basically the professionals, of the infrastructure management side, that's where the facility operator dashboard comes into place. That's mainly for the people or organizations that are sharing data with the FuzionView engine. And then you've got a system operator dashboard, which is basically pretty much everything in number 2, but with the additional capability of seeing everybody's data inside the FuzionView system. So that's the group that actually manages the ticketing system. We'll talk about all 3 of these here coming up. So we jump into the ticket viewer. That's intended for the design engineers, locators, excavators. There's a couple other categories of users, but these are the 3 main ones that we're working on. We've been focusing primarily on the design engineers in the near term. Locators and excavators will have a couple of little tweaks to the interfaces here, but for the most part, what comes after this is going to be available to these 3 types of users. So if we look at the ticket viewer itself, it's pretty simple, and it's designed to be that way. The idea is to be able to convey the information about what is where, not necessarily about who owns it, although that information is available as well. But the idea is that we're trying to just explain that it's this type of infrastructure, and this is where it's located at. And in a very simplified form. Again, we're looking at that dash line. This is a little bit further zoomed out or a bigger area for a dig ticket, but that dash line and the solid line still represent the ticket and the 100-foot buffer. You have other information that's available inside this ticket viewer related to the metadata of the ticket. So, the ticket number, ticket type, which data providers are sharing data, how many entities they're sharing inside of this particular ticket. And then you have options here available for downloading the actual feature data, so you can pull them into your engineering system. These will only be available once a licensing agreement has been signed by the end user, and all of the data is available from the data sharing side. So in other words, they'll have to sign an agreement to be able to get that level of access. And then there's also a link in here to go back to the original ticketing, the Gopher State One Call ticketing system. So that's where that link is on the bottom there is what that's for. And then you also have layer control. So all of the features can be turned on and off and categorized by the feature types. These are the standard feature separations that FuzionView is using to distribute the data. If there's a number on the far right column there, that means that some data has been captured and put into the presentation here. If there's a no data indicator there, that just means that there's no oil and gas steam, no potable water, and no reclaimed water infrastructure representations in the interface. You've got different types of base maps and stuff that can be added into the ticket viewer. So, we can just kind of glance over that. But the idea there is that, we can provide different types of base maps. We are going to be adding parcels, for example, for the state of Minnesota. So that'll be added in. And there may be some protected areas. We've got the environmental pollution control. There's a couple layers on that kind of thing. And then sensitive areas for digging, those kinds of things that aren't necessarily infrastructure related, but more regulatory. And, as we move, we've been building this thing from the day one with the idea that it's mobile capable. So the idea is that this is a mobile friendly application. All of the interfaces that I'm showing you are all mobile capable. So it's all kind of focused on the idea that you could use this on your phone. Even the administrative side of it is set up so that it can be used in the field on a small screen. Different kinds of views of the same data, with the different backgrounds. And then the next chunk of operational capability here for the facility operators. So this would be the municipalities, anybody that owns infrastructure out in the public right of way where you would generally, run into it in a dig ticket. So, those other entities. They're going to have a different kind of jumping in mechanism to get into the interface, or get into the ticket viewing. So they're going to have a map that's going to be showing all of their tickets. And when I say all of their tickets, I mean tickets that have actually had data retrieved by the FuzionView engine from their services. And then they're going to have their own dashboard controls and be able to do different things with that view in that map view where they can jump in. And then there's also a version of the list basically in a tabular form where they can also jump into the ticketing view, and we can combine those two views into one so that they can jump around on the map and actually see the data related to their particular tickets that they're interested in. And then they can jump into the ticket, from either one of those interfaces. The facility operators also have the capability of managing their own data sets that they're sharing. So this particular data provider is actually sharing quite a few different layers. And the fact that they're all of these different layers, they're using their own names for defining what the data set names are and all that. When it's over on the FuzionView side, it's all homogenized into those 7 layers that I talked about earlier in the ticket viewer. And that's how the data is output from the FuzionView engine. The data providers also have the option of adding their own data sets. Once the connections and stuff are made behind the scenes, they can just go into this interface and add new data sets as well over time. The actual process of connecting up the data services are using a form like the form that you see here is what is used to be able to connect up. Right now, we're focusing on Esri or a WFS service. And there's just a couple of columns that they use for the data, the geometry types, that kind of thing, and then the layer name that they want to use inside of the interface to be able to define what they see in the previous slide. Once they've got the connection from the previous form validated, in other words, it's working, then they can manage the different data sets that they've got there. And this is the method that is being used to convert the data from their service into the FuzionView schema. So the idea here is this select statement in the middle here is what is being used, and this can be edited, or we can set it up in a standardized form. But the idea here is that this is how the data is converted from the service before it's put into the FuzionView engine. The FuzionView engine uses a very, very simple data schema. So everything with the beige header on it is provided by the facility operator. The ones with the FV header are applied at the FuzionView side, which is all indexing information. It's like who owns it, what's the ticket ID, it's just keeping all the information straight in the FuzionView engine. But this is the schema that is being used to manage all of the feature information that is being shared by the FuzionView engine. The feature class is that 7 or 8 data categories that we've got, that the data is managed and pushed out in the FuzionView engine. And then there's a couple columns in here that are optional, the green columns, and then a few of the columns also have domain values that we've already put into place for accuracy values and the status ID. Each facility operator also has control over who can see their data. So if you're registered with the system, the FuzionView system, you can be put into different facility operators access groups so that you can see their data. Where this would apply would be if a facility operator has a contractor that goes out and does a lot of their locating, or needs to be able to, an engineering firm that needs to be able to see their data. They can add that group into their access group on the security side, so that those other users can see their data the same way that they do. And they have control over that. So the interface here is showing you that you can add new users, and you can put them into your trusted viewer list. The way that you would add a new user is to basically just send them a form like you see here, and they enter their email address, and then there's a validation process that happens behind the scenes. The last piece that we need to talk about here is the system operations side. So how is the system, the FuzionView engine, run? The system operator basically has all of the capabilities of a data provider, with the addition that they can see all of the data providers. So they're going to be able to troubleshoot and manage the data as it's coming into the system, and then be able to see everybody's data. The idea being here is that the only ones that see this are the actual entities that are running the Gopher State One Call system. So that's the only ones that will have this type of system access to everything. So you can see here we've got 10 different data providers that are sharing data, and you can jump into each one or any one of those and grab information from each one of the data providers. You can see that there's a couple of extra links in here for the data providers. In other words, there's a data providers list here right in the middle of that menu that doesn't exist in the operators or the data providers version of this interface. They also have the map control in this particular interface. You jump into it in the same ways that you would in the data providers side. You have the same controls over being able to add new data providers. This is getting up to that one, level above now. So now we're talking about listing out the data providers, not necessarily, down a level about the users that a data provider can manage. This is managing the data providers and how their interfaces get added into the FuzionView system. As we've been progressing with the project, we've been putting together a fairly comprehensive documentation set. So the documentation for the project is going to be available as well. And it's becoming very fleshed out. I mean, we're kind of on the tail end of the project development now. So this documentation aspect has really been kind of flowing real well and pulling together real nicely. If you wanted to look at the project from a very high level view, the way that the project works is the Gopher State One Call system actually gets the request coming in for the ticket, what type of ticket that they want to that is being managed. Once that ticket is received by the Gopher State One Call, the basic metadata for the ticket, the boundary, polygon, the information about who's requesting the ticket, what type it is, the begin, end date, that kind of information. That's all recorded by the FuzionView engine and stored in the FuzionView database. Once that data is captured and pulled into the FuzionView engine, the FuzionView engine will go out and grab any data that is overlapping the polygon of interest for the ticket from any of the data providers that are registered to share data with the FuzionView system. So the FuzionView engine handles all that, pulls that data back into the FuzionView engine itself, and then transforms it. So likely the data is being managed in different projections, for example, mapping projections, so different coordinate systems. That is converted into the FuzionView generic projection that we're using and pushed out into, when the data is distributed, the data is already transformed into this unified layer. And then all of that information that is pulled in from the database is also converted on the fly from the generic or into the generic FuzionView schema from whatever schema they're providing in their services. The data providers can actually contribute their information in a FuzionView ready form. So we can send them a sample of the schema, as a geo package, for example, and they could use that as a sample of setting up their services in a FuzionView ready form. Or we can go back to that SQL statement that I showed you on the one interface where we can convert their data as is into the FuzionView system as another option. So once that data is converted and is ready to be distributed, the FuzionView engine can distribute that data back to whoever requested it. Obviously, a piece of it goes back into the Gopher State One Call system, but then the engineering team, locate team, excavation team all will have access to that converted data and how that all pulls together. There's some security and regulatory issues that we have to kind of pay attention to. There's no laws preventing the data sharing. There's a chance with this project to set standards. We're using some of the ASCE standards as kind of a guide as we're moving through building and developing things, but they're generally only guidelines right now. And then one piece that we've actually been paying quite a bit of attention to is the Federal Geographic Data Committee 2005 guidelines. Even though they're pretty old, they actually apply very well to what we're working on. So that's actually helped us quite a bit. We've got some agreements that we're building for, the facility operators versus the data end users, and then how the facility operators can control who accesses what. So the usage limitations, those kind of things, disclaimers about the data, accuracy, those kinds of pieces. And that's all I've got. Sorry, I dropped off abruptly there. I left off a couple slides because I only had 30 minutes.
Thanks, Bob. That was great. We have questions. Do you have time for Q&A?
Sure.
Great. I actually, so we have, so yeah, folks, put your questions in the Q&A. We have a few. I had an idea to start off with. I'd be very curious. What has the response been by the beta users?
From the technical aspect, so every organization that we've talked to from the technical side and the kind of the middle management or middle level administrators see the benefits of it immediately. A lot of it is kind of some of the stumbling blocks are related to the higher end, making sure that they're providing information in the way that they need to, that it's secure, those kinds of things. There's some organizations that flat out are like, we don't know about this kind of thing. We expected that as we move forward. We're not expecting everybody to jump on board. There's no law making them do that. Although there are some new legislative items that are kind of playing into this that are interesting. basically in 2026, you're going to have information recorded as they're exposed in any kind of a digging for the state of Minnesota. And then there's different dates that apply for different sizes of organizations, but this is a real recent thing. So it's playing right into this whole idea that we can share data now, and they're going to need to be able to do it here down the line within the next couple of years.
Cool. Let's get to some of these questions. Are there access controls for who sees what data in the system?
Um, yeah, so the data or the whole system is actually fairly secure in that the data that is being pulled into the FuzionView system is actually converted into the schema for FuzionView. That's one kind of a security layer, I guess you'd say. And the secondary piece of it is the only people that are going to be able to see it are the data provider, whoever the data provider is authorized to see it. The ticket management system is actually going to be, because we're only augmenting the existing system, the current existing ticket management system has all of security controls in place already. So everything that the FuzionView engine is going to do is just going to pass right through them. So the security side of it is already handled.
Okay, great. We're into our break, but we've got time for another question. Here's another broad one. What type of future do you see for the project?
Like I say, I alluded to it in the presentation a little bit, but I think where, from my perspective, and I've had experience with this in the past on applications that I built for the different things in the past that I built. Once you get a system in place that's very easy to use, and the FuzionView engine and display aspects of this are very simple to use, people start using it. And I know that sounds like a duh kind of statement, but the easier you make something to use, the more likely people are going to use it. Once they start using it, then they see that the data needs to be improved. So the point of it is that if you make it easy for the data sharing to happen, you get more people that are starting to indicate that there's a problem here or there. That kind of percolates back over to the data managers, and then they start improving their data over time. And that happens. So the key to it is making the interface and the usability as simple as possible so that they just keep using it.